Morning all of you, and let's try a problem from theoretical calculus. And here is the first question. Is there a 1 1 and onto function f from 0 to 1 to 0 to 1 such that f dash equals f inverse? The second part of the problem is there any bijective function which is 1 1 and onto from 0 to infinity to, let's say, 0 to infinity such that f dash equals f inverse. And third, we can tell if there are 1 1 and onto functions same from real to real such that f dash equals f inverse. So let's try these three problems. They are really conceptual and a very good food for JEE. Let's start with attacking 3 first. Okay, so what we'll do is we'll prove by contradiction first. Suppose if there is a function from R to R such that f dash equals f inverse. Now we know if a function is continuous, indifferentiable, which is from R to R, so I'm assuming it's differentiability because f dash I've defined. So function must be monotonic. Okay, because the prime criteria for inverse to exist is bijectiveness. It must be 1 1 2. So here suppose if function is monotonic, let's take it as strictly increasing. So suppose if the function is strictly increasing throughout real number f of x, so clearly its inverse function will be the mirror image of this. So it's also strictly increasing. Now since function f of x is onto, so there must be a point alpha at which the function dies, f of alpha dies, right? And I can see for the function derivative is always positive because I took a case 1 of strictly increasing. So I know f dash is always strictly positive. Okay, you can make it increasing also, so greater than equal to 0. If equality occurs at discrete point, that is fine. But now the problem is corresponding to alpha, if I'll see the point less than alpha, still we have slope at 0. But there exists a point beta on the function f inverse x where beta is I. Right, so if I take any point, any value of x less than beta, we'll have f inverse x value is negative. Any values of x which is more than beta, that will give f the inverse x as positive. It means f inverse is positive and negative depending upon whether x is more than beta or less than beta. But f dash is monotonic, so it's always positive, right? So this definitely cannot occur. So the answer is there is no such function in the third case. Let's try the first case now, and before we go and attack the second case. So again, suppose if such function exists, that is f dash equals f inverse for the first case. So we can clearly see f inverse assumes only positive value because the codomain is 0 to 1. Okay, and it can be shown very easily, like suppose if g is a function which is going from a to b to r, and if it is continuous, right, and 1 1, then g is definitely either strictly increasing or strictly decreasing. Fine. If it is continuous and 1 1, so it's a well established fact, like g of x is either continuously increasing or it's continuously decreasing in that interval, means it will be monotonic. Okay, so using this result, what we can tell? So I can tell that limit x tends to 0 plus for that function f of x, because I know we have function f of x which is between operating from 0 to 1 and 0 to 1, right? So this limit is some u, and limit x tends to, let's say, 1 minus f of x is some b. Now we know since function has to be 1 1 and onto, it means this u must be 0 and b must be 1. There is no other out, because you can't draw functions like this in fact. Okay, then the function is all to 1 1 but not onto. It means it has to assume 0 and 1 definitely. So one of the rough graph of function will be something like this, right? So this may denote f of x is strictly increasing or strictly increasing like this. So in this case the function has to be strictly increasing, there is no way out. Now we have to show like there is no such point between 0 to 1 in the open interval where the inverse function f inverse x, let's say suppose this is f, then that guy is f inverse x, will be equal to derivative. It means if I take any point and find the slope value, let's say slope value is 0.72. Okay, now at that point you can be sure the height value can never be 0.72. Okay, so that's what you have to do actually algebraically. So now it's not very difficult because we know the function now is when operating from 0 to 1 to 0 to 1 now, right? So if such function is onto, I can feel as if we extend f to a continuous bijection, let's say suppose instead of this I extend f to a continuous bijection 0 to 1 to 0 to 1, then I can tell function is continuous in this interval and is differentiable in open interval 0 to 1, right? So by mean value theorem, clearly f of 1 minus f of 0 divided by 1 minus 0 equals f dash u for some u belonging to 0 to, and we know in this case, our case, 1 minus 0 by 1 minus 0 is going to be 1. So f dash u should be 1 for some u between 0 to 1. But I know since this is equal to already f inverse, okay, u. So that's equals f inverse u, because we are assuming they are equal at some point, let's say at that point u. So this is never possible. Why? Because f inverse u anyway that will belong to 0 to 1, and f dash u we got exact 1, so there is incompatibility, hence not possible. Now some of you tell, sir, how you are taking the same u. So let's say f dash u equals 1 even if it is f inverse b at some other point also. Actually I wanted to find the derivative at some point. There exists some point minimum where derivative is 0. Even at the other point also, okay, it cannot be equal, because the point is this will always lie between 0 to 1. Okay, so slope if it is 1, then it's incompatibility at least for 1 point. So that proves the result for part 1. Hence the answer is this is also no such function is possible. Now part 2 is a bit technical, because if f is from 0 to infinity and it's going to 0 to infinity, means from positive infinity to positive infinity, then is it possible to have a function? Now there can be a chance, because suppose if you have a strictly increasing function like this, then its inverse is going to be this, right? Still it will be a strictly increasing. So now chances are there, like there can be point where okay, the slope value and the inverse value might meet. Clear? So the slope value, maybe the slope value is going to be something high and the inverse output is going to be something high. So here possibilities can be there. We are not sure whether exactly it will be there, but it feels like possibility maybe as of now. So one way to actually try the answer is you can look for some function having particular property, and the good step will be maybe to hit some common function. So let's say if I start with f of x equals axt for some positive a, okay, and t as in part first we have already seen, then what we can find, f inverse x is not very difficult to find here. We'll get a to the power minus 1 by t, x to the power 1 by t. And what is f dash x? F dash x is at x to the power t minus 1. So if we equate, we are getting an expression is 1 by t equals t minus 1, which gives, and at equals a to the power minus 1 by t. Now clubbing both these equations, we get the value of t as a golden ratio, which is 5, 1 plus root 5 by 2. 1 plus root 5 by 2 is given a special name in mathematics as golden ratio. तो यहाँ से the function we already got is this 5, 1 to the power 1, 5 to the power 1 minus 5, and x to the power 5, right, where 5 is golden. So yes, indeed I have found a function which is possible to have inverse height and its derivative to be equal at some point, which I was guessing. So I hope you understood the problem. Now the more challenging problem will be, let's say if I ask you to find all intervals a comma b for which there is a bijective and differentiable function from a to b to a to b, such that like f dash equals f inverse for all x belonging to a to b. So that could be possibly be more generalization of that, and to find that will be quite challenging. It might go beyond JEE. But these three configurations was JEE relevant, and in recent days JEE already asks many problems on theoretical calculus. So I urge you to read calculus very minutely, and especially those who are preparing for JEE Advanced. Please take it very seriously to understand the physics behind mathematics. Thank you. Have a good day.